Almost all of us have heard of the Apollo 11 moon landing, and in this speech I'd like to propose a return to the moon, although not only a return to the moon, but the colonization and the founding of a moon base. The establishment of a moon base could be crucial to the exploration and the study of the solar system, which could affect all of humanity. A permanent settlement upon the moon will act as a vastly important infrastructure, which can reduce the cost of off-planet travel, and it would allow for the development and improvement of technologies which could benefit everyone on Earth. While I'm not involved with or know anyone involved in space travel, it is an incredibly important field which holds near endless opportunities ripe for the taking. We already possess the means for setting up a moon base as a society. We merely lack the motivation to take the steps necessary, despite the immense rewards which can be received through taking such an endeavor. I would like to convince you of the viability and opportunity of building a moon base. The challenges an endeavor would propose, such as sustainability, shielding from radiation and microgravity, as well as the benefits of a moon base, could be immense, as the moon base could provide a launching pad for future missions, a research station in the various fields, and potentially a mining outpost. There are many challenges that will be encountered with the establishment of a moon base. The challenges will include microgravity, maintaining an atmosphere, radiation shielding, micrometeorites, hard vacuum on infrastructure, lunar dust contamination, severe temperature gradients, feeding the crew, finding qualified individuals, the massive equipment, finding suitable power source, the cost of the base, the medical risk, and the political challenges. These are all problems that will be faced if we establish a lunar base. Microgravity will be significant, and that it will have to be combated constantly if an individual seeks to take up residence on the moon. The effects of microgravity on human muscles can result in a significant loss in physical strength by several percentage points from their starting physical strength. Exercise is one of the primary solutions to this problem. Explosive exercise, which can make use of heavy, fast-twitch muscles. Radiation shielding will be one of the most vital components in establishing a moon base. There are two distinct types of radiation shielding, passive shielding and active shielding. Passive shielding is placing a physical barrier between a person and the source of radiation. The primary advantage of passive shielding is its ability to protect against any form of radiation, whether it's positively charged, negatively charged, or neutral, and is one of the most reliable forms of shielding. Active shielding takes inspiration from the magnetic field of Earth, which can be used to both deflect and trap portions of radiation from space. Many designers of spacecraft have proposed the use of large electromagnetic fields around a spacecraft, space station, or moon base to mimic the magnetosphere of Earth. Feeding the moon base population will require the crew to subsist off a plant-based diet, with other types of food such as meat being shipped onto the moon base. It is possible to grow plants via a process known as hydroponics, which allows one to grow plants in water instead of soil, and use LED lighting as a substitute for sunlight. Now that we have concluded the many challenges involved with establishing a moon base, such as micrometeorites, microgravity, radiation shielding, and finding qualified individuals, we will now assess the benefits of building a moon base. If we want to build a moon base, there must be a wide variety of benefits that can be attained by doing such. In the establishment of a moon base, we can benefit from mining on the moon, observing planetary movements from the moon, access to new natural resources, support new space missions, support travel to Mars, tourist destinations, locate black holes, and create a more accurate topographic map of the moon. Mining on the moon is one of the many possible benefits, as it has raw materials that are both common and rare on Earth exist on the moon. Many of the most common materials, such as iron, titanium, aluminum, silicon, and calcium, would be easier to mine due to the lower gravity. The construction of the moon base would allow access to new natural resources on the moon, such as helium-3 along with the lunar regolith. Helium-3 is significantly more abundant on the moon than on Earth, 10 to 20 parts per billion. It has been estimated that the regolith of the moon contains around 1,100,000 metric tons of helium-3. A high number of individuals have proposed to exploit the lunar regolith and use helium-3 for nuclear fusion. Lunar regolith is a blanket of loose, unconsolidated, heterogeneous, superficial deposits covering solid rock. In the founding of a moon base, a significant number of infrastructure will be required. One of the primary requirements will be to provide structural materials for the infrastructures. Unprocessed lunar soil can be processed into usable construction materials through techniques such as sintering, the cast basalt method, 3D printing, and liquefaction, and hot pressing. Supporting new space missions could be the primary purpose of a lunar base and its crew. Due to the moon being significantly lower gravity than the Earth, this will make launching missions into space easier and cheaper. Since we have determined the benefits of a moon base, such as being a ground launching ground for future space missions, mining the moon of its raw materials, and accessing new natural materials present on the moon, we can discuss possible near-future base design as well as an overall shape of the habitat and what it could be made of. Inflatable designs have been a favorite design for a while due to their use of lightweight materials and optimization of living space. Due to the moon's surface having no atmosphere, the habitat would have to be highly pressurized to simulate terrestrial atmosphere. Due to the forces of the internal gases acting outwardly by the maintained gas pressure, structural integrity of the inflatables can be assured. The primary problem of inflatable habitats is that they provide little protection from things such as micrometeorites. Moreover, catastrophic depressurization could be caused by a high-velocity projectile striking the membrane, resulting in a weakness. Although one solution to this is covering the inflatable habitats with the protective layers of lunar regolith and the use of extensive fail-safes. The hangar structural design would be the most optimal for living volume, floor space, habitat height, and functionality, alongside life support equipment and storage. The shape of the load-bearing arch is vital to the design, as it allows for structural stresses to be evenly distributed. The biggest stress upon the hangar design will be the internal pressure acting outward. Universe Today states that the interior would need to be held at terrestrial pressures. The pressure against the gradient from the interior to the vacuum exterior would exert a massive strain on the construct. This is where the arches will become essential. As there are no corners to the base, there will be no weak spots to degrade its integrity. Once the habitat modules of the moon have been constructed and secured, further additions can be made as needed. In this speech, we have examined the benefits of building a moon base, and the challenges involved in doing so. Furthermore, a space habitat may be constructed and its general structural designs.